Dear students, welcome to CBSE Maths World. Let's discuss the first chapter in CBSE 10th standard maths, and the first chapter is chapter 1 real numbers. We know that 8th standard first chapter is about a number system, 9th standard also the first chapter about a number system, and 10th standard also the first chapter is about this number system, and here they are saying real numbers. So let's discuss what are the important number system is studied in the small classes. First we studied about n. N is what? N is known as the natural number or counting number. Which are the natural number or counting number? It starts from 1 comma 2 comma 3 comma 4 comma etc. These are known as the counting number or natural number denoting with the letter n. Next is whole number. Whole number is denoting with the letter capital W. Whole number, what is the difference between the natural number and whole number? If you add 0 in front of the 1, that is 0, 1, 2, 3, 4, etc. etc. These are known as the whole number. So the first is the counting number or natural number. Natural numbers are 1, 2, 3, 4, etc. Next is the whole number. Whole numbers are 0, 1, 2, 3, 4, 5, 6, etc. etc. Next we discussed about the integer. Integer usually denoting with the letter Z. Okay, actually we have Z plus, this discussing about positive integers, then Z minus. Z minus is what? Z minus is negative integers. Which are the positive integers? Positive integers are 1, 2, 3, 4, 5, 6, etc. etc. These are known as the positive integers. Negative integers, which are the negative integers? Negative 1, negative 2, negative 3, etc. are known as negative integers. So there is a confusion. What about 0? Whether 0 is an integer or not? Yes, 0 is also an integer. 0 is also an integer. So integers actually we can divide positive integers, that is 1, 2, 3, 4, 5, 6, etc. Then negative integers, negative 1, negative 2, negative 3, negative 4, 5, 6, etc. Then 0 is an also integer. Then in 9th standard we discussed about the rational numbers. What are the rational numbers? Rational numbers are the numbers denoting with the letter Q. That is any number if we can return in the form P by Q. If any number written in the form P by Q, that is one number divided by another number. One number divided by another number. Example, 2 by 3. 2 by 3 is a rational number. Negative 4 by negative 6 is a rational number. This 0 is also an rational number. So any number, if we can return in the form P by Q, that is one number divided by another number, this type of the numbers are known as rational numbers. Only one condition is that denominator never ever equal to 0. Then we discussed about irrational number. Irrational number is what? Number we can return in the form P by Q is known as rational number. If we can't return in the form P by Q, okay, example pi. Pi is an irrational number. Pi is an irrational number. Root 2. We know that for root 2 we didn't get exact value for the root 2. But when we are considering root 4, what is the value of the root 4? Root 4 is equal to 2. Root 9, what is root 9? Root 9 is equal to 3. So root 4, root 9, this type of the numbers are also rational numbers. When we are taking the root 2, we didn't get the exact value for the root 2. It's 1.4, something is going. So that's why root 2 are irrational numbers. So the collection of this all type of the numbers, natural numbers, irrational numbers, whole numbers, this type of all the collection, we can say that this is known as real numbers. Okay, so definitely there will be opposite for the real number, that is known as the imaginary number. Imaginary number is the, if the root inside the root, if negative comes, we can say that type of the numbers are imaginary numbers. So real numbers is actually, it's a union. Union means collection of all rational and all irrational numbers. Okay, what is the real number? Real number is the collection of rational numbers and irrational numbers. Okay, let's discuss the next topic. The next is fundamental theorem of arithmetic. What is the fundamental theorem of arithmetic? Very, very important one is this one. Fundamental theorem of arithmetic. Look here. Every composed numbers can be expressed as product of primes, and this factorization is unique apart from the order in which the prime factor occur. You need to study according to how I am writing here. Every composed number, take any composed number that you can express it as product of primes, and this factorization is unique apart from the order in which prime factor occur. I will explain what is this one. Take a composed, we can actually divide a numbers as prime and composed number. Example, 1 is not a prime number, not a composed number, so no need to consider about the 1. Consider 2. 2, only the possible way to express the 2 as 1 into 2. So 2 is a prime number. This is a prime number. but 2 is a prime number. Next, consider 3. What about 3? 3 you can write in the form 1 into 3. So 3 is a prime number. Next, 4. 4 you can write in the form 1 into 4, otherwise 2 into 2. So we have one more method to express 4 other than 1 into that number. So this is a C. C means composite number. And look here, every composite number can be expressed as the product of primes, and this factorization is unique apart the order in which prime factor occur. So this way 6 is a composite number because 6 you can return 2 into 3. So consider 6. 6 you can return in the form 2 into 3. 2 is a prime number and 3 is also a prime number. That's why they are saying this prime factorization is unique. It means that if you are doing 6, you will get the 6 as 2 into 3. No other value you will get. That's why they are saying it's unique. Every times if you have prime factorize 6, you will get the answer as 2 into 3. And this sentence also, apart from the order in which the prime factor occurs, the order is not at all important. How? 6 you can express in the form 3 into 2 also. Okay, this is also 6, this is 6. So 6 you can written the form 2 into 3, 6 you can written the form 3 into 2. Though that's why the order is not at all important. You can express any composite number, take any composite number. Example, one more composite number, 10. 10 is a composite number. 10 you can written the form 2 into 5. This is the only way to express the 10, 2 into 5 or 5 into 2. That's why saying it is unique. Everyone will get the same answer, 2 and 5. And the order is also not at all important, 2 into 5 or 5 into 2. This is known as fundamental theorem of arithmetic. So what is the fundamental theorem of arithmetic? Take any composite number. Okay. And you can express that composite number as the product of primes. And the prime factorization is unique apart the order in which the prime factor. That's why same sentence, every composite number can be expressed as product of primes. And this factorization is unique apart from the order in which prime factor okay. Hope it's clear. Express each number as product of primes. So using the fundamental theorem of arithmetic, we know that every composite number can be expressed as the product of primes. And look at the question. The question is express each number as the product of the primes. The first question is 140. The second question is 156. The first number is 140. So how you can write 140? Then prime factorize. With 2, how many times? 70. Then with 2, 35. In 35 with which number? 5. 5 is equal to 7. Then with 7 only one time. So how many 2's are here? 2, 2. So you can write 2 raised to 2 into. Then only 1 5, that is 5. Only 1 7, that is 7. So 140 we express as 2 square into 5 into 7. The next number is 156, right? 156, then prime factors with 2 because 156 is an even number. So you can divide it with 2, then you will get 78. Then again with 2, you will get 39. Then with 3, you will get 13. 13 is a prime number, you can stop here. So 2, how many times 2 comes here? 2 times, so 2 raised to 2. Only 1 3, that is 3, or you can write, if you want you can write 3 raised to 1 also, that is not a matter, and 13. So this is the answer of how we express 156. So 156 is actually equal to 2 square into 3 raised to 1 into 13. And the question is, show that 8 raised to n cannot end with digit 0 for any natural number n. 8 raised to n cannot end with the digit 0 for any natural number n. Remember one thing, if a number is end with the digit 0, its factors, there must be a factors as 2 and 5. 2 and 5 must be a factor. If any number end with the digit 0, example 30. 30 end with the digit 0. 30 is end with the digit 0. So if you are factorizing, prime factorize this 30. How you will get 30? With the 2, you will get 15. Again with the 3, you will get 5. So 30 you are expressing as 2 into 3 into 5. 2 into 3 into 5. So look here, 2 is a factor, 5 is a factor. So any number end with the digit 0, there must be 2 and 5 as factor. But the question here, show that 8 raised to n cannot end with digit 0. So 8 raised to n. Actually, what is 8? 8 is 2 into 2 into 2. Okay. 8 you can express as 2 into 2 into 2. So all raised to n. That is 2 into 2 into 2 means 2 raised to 3 all raised to n. Or simply you can write 2 raised to 3n. Or simply you can write 8 raised to n is equal to 2 into 2 into 2 all raised to n. 2 cube all raised to n. Here 2 is the only factor. Here 5 is not a factor. Therefore, it will never end with the digit 0. What do you want to write? 8 is equal to 2 cube all raised to n. That is 2 raised to 3, 2 raised to 3n. Here 5 is not a factor. Here 5 is not a factor. Therefore, 8 raised to n never end with the digit 0. Never end with the digit 0. Check whether 6 raised to n can end with the digit 0 for any natural number n. This is a question, CBSE, previous question, CBSE 2011 question. And once again, I am reminding you all that if a number ends with the digit 0, there must be 2 and 5 as there is a factor. 2 must be there, 5 must be there as a factor. Look, the 6 raised to n. 6 raised to n, how you can prime factorize 6? 6 is equal to 2 into 3. So this is 2 into 3 all raised to n. You can write 2 raised to n into 3 raised to n. Here where is 5? No 5. So you can write here 5 is not a factor. Here 5 is not a factor. Therefore, it will never end with digit 0. Therefore, it will. This is the answer. Once again, 6 raised to n. Here 6 can express in the form 2 into 3. Here 5 is not a factor. Therefore, it will never end with the digit 0. Then the next question. The next question is find the HCF and LCM of 10 and 120 and verify HCF into LCM is product of the prime product of the two numbers. We need to find HCF of 10 and 20. How you can find HCF of 10 and 20? You can use the prime factorization method. So 10 you can return in the form 2 into 5. And 20 you can return in the form, 120, how you can write 120? Look, 120 with the 2 you can return the form 60, again with the 2 it is 30, then with the 2 15, then with the 3 5. Stop here. So how many 2? 3 2. So it is 2 raised to 3 into 3 raised to 1 into 5. So HCF, while we are considering the HCF will take the prime numbers that is common and we will consider the smallest, the lowest factor. So 2 is actually common. Here and here you will get 2 and 5 will also you will get. Where is the less power? Less power is 2 raised to 1. So 2 raised to 1 you need to check. And when we are considering 5 raised to 1, 5 raised to 1, same value here. So in it value you can consider 5 raised to 1. So 2 into 5, that is 10 is the HCF. HCF is equal to what? HCF is equal to 10. And LCM. LCM is what are the numbers we left out after taking the HCF? That are numbers, product of that numbers are the LCM. So you want to take 2 raised to 3 here and 3 raised to 1 and then 5. 2 raised to 3 is equal to 8. So 8 into 3 into 5. 8 into 5 is equal to 40. 40 into 3 is equal to what? 120. So this is 120. Next, we need to verify whether HCF into LCM as the product is equal to product of the two numbers. What is the HCF here? HCF is equal to 10. What is LCM? LCM is equal to 120. So you need to find what is HCF into LCM. The answer is 10 into 120, that is 1200. And product of two numbers. Product of two numbers is equal to 10 into 120, that is also equal to 1200. Look here, so both are equal. So you can verify that HCF into LCM equal to what? Product of two numbers. Hope is clear to everyone. Then the next question. The next question is, given that HCF is equal to two numbers is equal to 9, you need to find LCM of the two numbers. HCF of 306, 657 is equal to 9. We need to find LCM of 306 into 657. So what is the formula? The formula is HCF into LCM is equal to what? Equal to product of two numbers. HCF into LCM is equal to product of two numbers. So what is the HCF here? HCF is 9. We don't know the LCM. Okay. And the product of the numbers are 306 into 657. Okay. So how you can find the LCM? To find LCM, you need to transpose this 9 to here. Into 9 become as divided by 9. So it is 306 into 657 divided by 9. Answer is 22338. Question is, prove that 3 plus 2 root 5 is an irrational number. What is irrational number? Rational numbers are irrational number. We discussed. Rational number is a number we can written in the form p by q. That is one number divided by another number. This type of the number is irrational numbers are the number we cannot written in the form p by q. Okay, we cannot written in the form p by q, that are known as the irrational number. So the question is, how we can prove that 3 plus 2 root 5 is an irrational number? The method is so simple. Let first assume or suppose 3 plus 2 root 5 is rational. What actually we need to prove that it's an irrational. So we assume or suppose that 3 plus 2 root 5 is rational number. We know that any rational number we can return in the form p by q. Take any rational number that we can return in the form p by q. So 3 plus 2 root 5 is equal to a by b. What is the speciality of a and b? A and b are co-prime integers. A and b are co-prime integers. These are the co-prime integers. Co-prime means no common factor other than 1. Co-prime integers. Okay, that is any rational number we can return in the form one number divided by another number. Both numbers are integers. That's why we are writing 3 plus 2 root 5 equal to a by b, where a and b are co-prime integers. So transpose this 3 to here. So what you will get? 2 root 5 equal to a by b minus 3. So if you cross multiply, you will get 2 root 5 equal to what? A minus 3b all divided by b. 2 root 5 is actually 2 into root 5. Transpose this 2 also here. So you will get root 5 is equal to what? A minus 3b. This into 2 will come as a divider by 2. So 2 into b, 2b. We know that a is an integer, b is an integer, 2 is an integer, 3 is an integer. So actually root 5 now in the form integer divided by integer. Is an integer divided by integer. But what is integer by integer? Integer by integer is rational number. Now it's a rational number. Now we return root 5 as rational number. Actually now the root 5 is equal to what? Root 5 is rational number. But we know that what is root 5? Root 5 is actually irrational number. Root 5 we didn't get a specified value for the root 5. Point, and the point is not ending also. The decimal part is not ending also. Well, we are considering root 4. Root 4 value is 2. So we can say that root 4 is rational number. Root 49. What is root 49? 7 into 7 is 49. So root 49 is 7. So root 49 is an rational number. Like that, you will not get any correct integer value for root 5. So root 5 is actually irrational number. But what we got it says rational number. But what is root 5? Root 5 is irrational number. So it contradicts the fact that root 5 is irrational. So you want to write here, it contradicts the fact that root 5 is irrational. Root 5 is actually irrational. So it contradicts the fact that root 5 is irrational. Therefore, our assumption wrong. Assumption is wrong. Therefore, this 3 plus 2 root 5 is irrational number. So we need to conclude like this way. Therefore, our assumption is wrong. 3 plus 2 root 5 is irrational number. Once again, what I want to do first? First, suppose that we need to prove that it's an irrational. So suppose it's a rational number. Any rational number can be written in the form a by b. A and b are co-prime integers. So we wrote 2 root 5, 3 plus 2 root 5 as a by b. Then we express root 5 a minus 3b by 2b. But it's an integer by integer rational number. Now we are saying that root 5 is rational. But actually what is root 5? Root 5 is irrational. Therefore, it contradicts the fact that root 5 is irrational. Therefore, our assumption wrong. Therefore, 3 plus 2 root 5 is an irrational number. Hope is clear to everyone. Thank you.